Okay, YouTube, in this module of videos, we're going to be focusing on this number that we refer to as the determinant of a square matrix. And so let's go ahead and touch on a few basics here. Starting with this, we say that every square matrix can be associated with a real number called its determinant. And so one thing we want to mention about this is because it's just a real number, we say that the determinant of a matrix being a real number is a scalar, okay? So that's just kind of an important thing to mention, given that we do a lot of things with matrices and say a matrix plus a matrix, you get a matrix answer. But if you were to do like 2 times the determinant of a matrix, that's really a scalar times a scalar, so you get a scalar answer, and there's a difference between the types of answers you get. So the determinant of a square matrix is called, I guess the determinant of a square matrix is a number that is associated with that square matrix. And there are different methods for calculating it. In this particular video, what I want to be clear on is this. We have the determinant of a 2 by 2 being presented. So this is only specific to 2 by 2s, specific to 2 by 2 matrices only. So what you see here will work to find the determinant of a 2 by 2 matrix, and it's a really easy method of finding it. It's just multiply and subtract. But essentially, don't try to use it on a 3 by 3 or 4 by 4 or any other matrix of any other order than a 2 by 2. So let's go ahead and start with this. We say that if we have some matrix A here, and I notice that A is specifically a 2 by 2, so I'll make a little note here. This 2 by 2 that's populated by A sub 1, B sub 1, and then A sub 2, B sub 2. You notice that I'm using brackets here to indicate that this is a matrix here, and also a capital letter. We say then that the determinant of A, and this is how we'd express this, we write DET and in parentheses A. So basically the determinant of whatever we put in here. We can also write this as this. Now you'll notice that this looks like absolute value. So we say looks like absolute value bars. And the thing here, absolute value bars, is that it's not absolute value. What we really mean is whenever you see these straight bars here, that it means the determinant of this matrix. And so I'll look at this quantity here in just a moment here. Whoops, let's do this. I need to click on my pen tool here. This right here, we'll look at that in just a moment. But for right now, I want you to know that the determinant of A, we could also write this way. And we could write A sub 1, B sub 1, A sub 2, B sub 2. And you notice the difference here is that this one has brackets and says that I am a matrix. And this one here says I'm a determinant, I'm a real number. So in order to find this real number, here's the neat thing about it. It's just a little pattern. We say A1, B2 times A2, B1. And so when you look at your matrix here, we say, where are A1 and B2? Basically, A1 and B2, these are these two quantities right here. We're going to take A1 times B2. And then we're going to take what we get there, and we're going to subtract off what we get when we take B1 times A2. And I do B1 times A2, but A2 times B1. I guess we would do the down row here, and then we'll do an up row. But basically, the product of the main diagonal minus the product of the opposing diagonal, where the main diagonal starts in the top left and goes down to the bottom right. So in order to find the determinant of, say, these matrices here, you can see clearly that these are 2 by 2s. You can just also see clearly that they just have vertical braces or vertical bars around it, I guess. There are no brackets. So we mean the determinant here. And so if I'm going to show my work here, I would say that this would be 2 times 2 minus 1 times negative 3. And all I've really done here is I said this main diagonal product minus the opposing diagonal product. And so let's go ahead and simplify this. We basically get just 4 here. Now 1 times a negative 3 is a negative 3, so we really get subtraction of a negative 3, which is a 7. So the determinant of this matrix here, we just say equals 7. I put a box around it. I say that these two things mean exactly the same thing, and that is the number that's associated with this particular matrix here as its determinant. So we say the determinant of this matrix here. Let's see if we can speed up this process a little bit. I know it's the product of the main diagonal minus the product of the opposing, or our down diagonal minus our up diagonal. So we say our down diagonal here is 2 times 2, which is 4, and our up diagonal here is 4 times 1, so we get 4. And essentially we get 4 minus 4, which is 0. Now I'm going to put a double box around this, and what we're going to do is we're going to label this. We're going to refer to any matrix that is a square matrix, of course. It has to be a square matrix to have a determinant, but any matrix that has a determinant of 0 is being a singular matrix, meaning it has a determinant of 0. And that's all a singular matrix means, but this is going to come into play a lot when we deal with systems that have either infinitely many or no solutions, just because of how their variables would scale into being perfectly the other set of variables and cancel out. But essentially, no solution in infinitely many solution systems, you'll see a determinant of 0. And also instances where, like we're trying to solve a matrix equation and there's no inverse matrix because it's a singular matrix. It's neither here nor there. What I want to say is that basically the determinant of a 2 by 2, we see that process is pretty straightforward. So let's look at an instance here where we have a different type of a matrix equation. We could actually express, this is an equation here, but express it as a matrix, and we can express matrices as equations. So let's take a look at this here. It says clearly the determinant of this 2 by 2, where this x plus 4 is our first row, first column entry in this matrix. So I'll put parentheses around it. And then also this is our second row, second column entry here. So when we multiply this out, we say, the product of our main diagonal here, which would be our x plus 4 times our x minus 5, that'd be some factored form of a polynomial, minus, always minus now, the product of the opposing diagonal here, so 7 times negative 2, which would be a negative 14. I'm going to put that in parentheses here. So let's go ahead and FOIL this out here. We say x times x is x squared minus 5x but plus 4x, and then minus 20. All of that there, essentially, minus the negative 14 would be plus a positive 14. And then we'll just go ahead and combine like terms. So we have x squared, looks like we get a negative x here in the middle, and then a negative 20 and a positive 14 and negative 6. So all of this here, remember in the beginning we said the determinant of this thing, which is this quantity right here, that is the determinant, it's equal to 0. And so essentially if I were to solve something like this, of course I'd try to factor it first. This one indeed does factor. If it didn't factor, I notice it's quadratic, so we could use the quadratic formula. And if it weren't quadratic and it weren't factorable, we'd just try to use division to solve it. So we say looks like x equals negative 2 and a positive 3 are our solutions here. And just to go to show that this does work here, if we were to go plug these back in, these two determinants here, I suppose negative 2 here and negative 2 here, and then we had a 7 here and a 7 here. But if I were to plug in, say, negative 2, x equals negative 2 here. That's a poor negative 2. Let's rewrite that, negative 2. And we were to plug in x equals 3 here. What I want everybody to see is essentially this. We get x plus 4, where this is negative 2 plus 4, which is a 2. And we say now a negative 2 minus 5 would be negative 7 here. And if we were to do this, we'd say I'd get negative 14 minus a negative 14. Essentially, we would get 0, which is what we ended up with in the first place. And also, if we were to plug in 3 now, 3 plus 4, which is a 7, look at this here. 3 minus 5 is a negative 2. You notice how they just kind of switch spots and switch parity here. But we also get negative 14 minus negative 14, which is absolutely 0. So in the next video, we'll take a look at how we can manually find the determinant of a 3 by 3 matrix. Where we had a special method for a 2 by 2, we'll have a special method for a 3 by 3. Cheers.